Good afternoon. My name is Tanmay Kayande, and for the last decade, I've been the trusted advisor for executives from startups to SMBs to enterprise scale organizations. I've found the patterns in the architecture of those that lead their field. I know because I've designed and developed their systems and processes using AI, platforms, models, and frameworks to positively affect billions of users. And now, bring my insights to you. Welcome to session 2. In our last session, we learned how to craft a good prompt. But what happens after you hit enter? The prompt is only half the story. The other half involves controlling how AI generates its response. Today, we're pulling back the curtain on those configuration settings. By the end of this session, you'll be able to explain how output length, temperature, top K, and top P settings control an LLM's response. And the second, you'll just be able to describe how the temperature, top K, and top P settings all interact with each other. To get there, we'll be looking at four key configuration concepts: output length, temperature, top K, and top P, which is also known as nucleus sampling. There's no quiz at the end of this. This is more so for you to know how this exactly works. Before we dive into each setting, it's crucial to remember one thing about how these models work. LLMs don't just pick one single word to come next. Instead, they predict probabilities for each possible next word or token in their vocabulary. The settings we're discussing today are the tools we use to control how a model chooses a single token from that list of probabilities. Let's start with the simplest one, output length. This setting is exactly what it sounds like. It controls the maximum number of tokens to generate in a response. It's important to know that reducing the output length doesn't make the model more concise. It simply causes the LLM to stop generating more tokens once that limit is reached. Next up is the temperature, which is probably the most common setting you'll adjust. Temperature controls the degree of randomness in model's choices. A low temperature, say close to 0, is deterministic and less random. It almost always picks the most likely token, which is great for factual prompts that need a predictable answer. A higher temperature leads to a more diverse, unexpected, and creative results because it increases the chances of selecting less likely tokens. Now, let's talk about top K. This setting limits the model's choices to the top K most likely tokens. For example, if K is set to 3, the model will only choose the next word from its 3 most probable options. The lower the K makes the output more restrictive and more factual, while a higher top K allows for more variety. Similar to top K is top P, or nucleus sampling. Instead of picking a fixed number of tokens, top P selects from a pool of tokens whose combined cumulative probability is less than or equal to the value of P. So if P is 0.9, it will consider the most likely tokens that add up to a 90% probability and pick from that group. So how do they work together? In a system like, for example, Vertex AI, the model first creates a pool of candidate tokens that satisfy both the top K and top P criteria. Then the temperature setting is applied to that smaller filtered pool to make the final random selection. Let's make this more concrete. Imagine we ask an AI to complete the sentence. The first person to walk on the moon was Neil. The model generates probabilities for the next token. Armstrong has 95% chance, Diamond has 2% chance, and Patrick Harris has 1%. With temperature set to 0, the model is deterministic and will always pick Armstrong. If we set the top K to 1, it also has no choice but to pick Armstrong, making the temperature and top P irrelevant. Similarly, if we set the top P to 0, the model will only consider the most probable token again, making the other settings irrelevant. This shows that extreme settings can cancel each other out. Setting the temperatures to 0 is the most common way to ensure a factual, repeatable answer. Let's do a quick check. If you wanted AI to help you write a serious business email, would you use a high or low temperature? You would want a low temperature for a more predictable and professional tone. Now, what if you wanted the AI to help you brainstorm a funny and imaginative slogans for a new product? Exactly, you turn the temperature up to get a more creative and diverse result. The main thing to remember is that you can balance creativity and predictability by tuning these settings. For factual tasks, use low temperature. For creative tasks, use higher temperature. As a great starting point, the Bootstrap paper suggests that a single correct answer, if that's what you're looking for, set the temperature to 0. For creative results, try a temperature around 0.9, and for something in the middle, a temperature of 0.2 is a good place to start. Now that we know how to configure the model's output, we're ready to dive into the first major prompting technique in our session. In our next session, we're going to be exploring zero-shot prompting. Thank you, and I'll see you there.